Hello everyone and welcome to Vidyarthi Point. Today our topic is permutation and combination. But before going deeper into this topic, let us know what is factorial. The factorial term will be frequently used in permutation and combination. So, whenever we say factorial of any number, it means the number and the product of the integers up to 1. That is, the factorial sign is either this or this. Let us take one example. Let us say we are taking factorial 5. We will write it in this way or in this way. Now, factorial 5 will be the product of this number, that is 5, and the integers up to 1, that is the product of 4 into 3 into 2 into 1, that is except 0. The factorial of a number will be the product of all the integers till 1. That is the product of all the whole numbers. This is what factorial is meant by. Now, let us take another example, that is 6. Now, let us take the product of all the whole numbers up to 1 from 6, that is 6 into 5 into 4 into 3 into 2 into 1. This is how we write factorial, and then we can find their values. That is, value of factorial 5 will be 5 into 4 into 3 into 2. That is, 5 into 4 will be 20. 20 into 3 will give us 60. Again, 60 into 2 will give us 120. So, the value of factorial 5 is 120. Again, now let us find the value of factorial 6. Again, we have to multiply 6 into 5 into 4 into 3 into 2 into 1. Here, we should look at this part, that is 5 into 4 into 3 into 2 into 1. Now, this part is similar to this. That means 6 factorial means that 6 into factorial 5. Factorial 5's value is 5 into 4 into 3 into 2 into 1. Similarly, this part represents factorial 5. So, in place of factorial 6, we can also write 6 into factorial 5. This part is important in solving questions. Now, here we can find the value of factorial 6. We know the value of factorial 5 is 120. Now, let us multiply 6 with the value of factorial 5. That is, 120 was the value of factorial 5. We will multiply 6. 6 0 0, 6 2 are 12, 6 1 are 6, 7. So, the value of factorial 6 will be 720. Now, let us look at the factorial n number. The factorial n will be given by n into n minus 1, n minus 2 into n minus 3 up to 3 into 2 into 1. That is, the factorial of any number will be the product of the number itself and the whole numbers smaller than that up to 1. This is how a factorial is represented. Now, let us look at the concept of permutation. What is permutation? Permutation is nothing but an arrangement. That is, in which way we arrange some things. Let us take an example of the number A, B, C. Now, we have to arrange them. Let us arrange them and find in what number of ways they can be arranged. A, B and C can be arranged as ABC, ACB, BCA, BAC, CAB, CBA. Now, these are the number of the possible arrangement of this number. We have to also note one thing, that in permutation the order is very important. That is, whenever you arrange a number, that is A, B and C A, C and B, these numbers have all the three numbers, that is this number also has ABC, this number also has ABC, but here they are counted as two different arrangement. Why? Because here the order is important, the order in which the number is taken. That is, here A is in first position, B in second, whereas C is in third place. Now look at this type of arrangement. Here A is in first position, C is in second, B is in third. So here the position of the numbers are changed, that is the order in which the letters are taken are changed. So here we are treating them as two different arrangement. This is what permutation is about. Permutation is an arrangement. Here the order in which you are arranging the things is also important. For example, if we take A, B and C and you have to fill them in these two places, that is you have to take two at one time. Here you have taken all the three letters together. Here out of the three letters you have to take only two. So taking only two, we will write A and B, then B and C, then A and C, again B and A, C and B, C and A. Here also AB, BA, AB, BA. Both of them have the same letters A and B, but here A is first, whereas here B is taken first. So here we are taking them as two different arrangement, and AB will not be equals to BA. Now let us look at another example. Let us say there are three types of balls. That is, one of them is red, another is green, and third number is yellow. Usually in permutation and combination, the balls is used in the questions. That is, you will be given the question of balls where you have to arrange taking some of the number at a time out of all the numbers. Here these three balls are to be arranged taking two at a time. Here out of three you have to take two in the arrangement. Here let us represent red as R, green as G and yellow as Y. Arrange them, that is taking two at a time. At first let us take red and green. This is one arrangement. Again we will change their order. We got another arrangement by changing the order. As we know, the order is important in permutation. Now green and yellow. Again let us change the order, yellow and green. We got another arrangement. Next red and yellow, again yellow and red. So here we have six type of arrangement, that is these three balls can be arranged in six ways. In six ways when we take two at a time, that is taking two at a time. Now let us look at a formula of permutation, which is N, P, R. Now here what is N and what is R? Here N will be the total number of items present or items available. Here the total number of items is the three balls. Here N is the 3, that is the total number of items available. Now what is R? R is the items that we have to take for the arrangement. That is, here taking two at a time. Out of 3 we are taking 2. Out of 3 we are taking 2. 3 is the number of available items which is denoted by N, whereas R is the number that we have to take, that is taking 2 at a time. Here 2 will be R. So NPR will be factorial N minus R. This is the formula of permutation. Here NPR is N equals to total number of items is 3. P R, taking 2 at a time. That is, out of 3 balls you have to arrange taking 2 balls at a time. Here P is your permutation. We have to always remember that in permutation, order is important. So this is your formula for permutation, that is NPR equals to factorial n by factorial n minus r. Now let us look at combination. What is combination? Combination is your selection. That is the major difference between permutation and combination. Permutation is an arrangement, whereas combination is a selection. Let us take the simple example of the 3 balls. Red, green and yellow. Now you have to take 2 at a time. Out of these 3 balls you have to select 2 balls. So red and green is one selection, green and yellow is one selection, yellow and red is one selection. That is, there are 3 types of selection. That is, while selecting 2 balls out of these 3, we get 3 types. Now in permutation there were 6 ways in which we can arrange. That is GR, YG, RY. This type was also present in permutation along with this number, but in combination we are only taking these 3 types. Why? Because in combination the order is not important, only the selection is important. Out of these 3, suppose you have selected red and green, here the order is not important, whether you have selected green at first or red at first. So here red and green is equals to green and red. Here the order is not important, whereas in permutation these were not same, but in combination these 2 are same. Because in permutation red was taken at first in this arrangement, but here green was taken. So in permutation we have treated them as 2 different types of arrangement, whereas in combination whether you take red at first or green at first, it doesn't matter, because it is about selecting. You can select any ball at the first place, whereas in permutation it was taken as 2 different arrangement. That is the major difference between combination and permutation. That is, in permutation order is important, whereas in combination order is not important. Now let us look at the formula of combination, which is NCR equals to factorial n factorial r factorial n minus r. The formula is quite similar to that of the permutation, whereas here factorial r is written at the denominator. We know that in combination the rearrangement of the elements is not taken. That is, if we have taken red and green, if we have selected this, then green and red is not taken because this is considered as same. So whenever we write factorial r in the denominator, it rules out all the possibility of the rearrangement in combination. Now let us take one example. Let us say there are 10 chairs and we have to select 3 at a time. There are 10 chairs and we have to select 3 at a time. Here let us apply the direct formula, which is NCR, that is factorial n factorial r factorial n minus r. Here NCR is 10C3. total number of available items, that is there are 10 chairs. So in place of n you will write 10. Now R is the number that we have to select out of the given items. So R will be 3. This will give us factorial 10, factorial R, that is factorial 3, factorial n minus R, that is factorial 10 minus 3, which is factorial 10 factorial 3 into factorial 7, that is 10 minus 3. Now let us write all the factorials. Factorial 10 will be 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Factorial 3 will be 3 into 2 into 1. Then again factorial 7 will be 7 into 6 into 5 into 4 into 3 into 2 into 1. Now let us cancel them. 7 and 7 will get cancelled. 6, 6, 5, 5, 4, 4, 3, 3, 2, 2, 1. They got cancelled. Now 3 will cancel 9 by 3. 2 will cancel 8 by 4. 3 4s are 12. 12 into 10, 120. So there are 120 ways of selection of 3 taking of 10 chairs, that is taking 3 at a time. There are 120 ways of selecting 10 chairs. Now let me explain it in a shorter way. Here we had factorial 10 and factorial 3 and factorial 7. Now this factorial 10 will mean 10 into 9 into 8 into factorial 7. We can also write it in this way, or factorial 10 can also be written as 10 into factorial 9. In the first time we have explained that factorial 6 was 6 into factorial 5. Now this can be written as 10 into 9 into 8 into factorial 7. Let us expand factorial 3, that is 3 into 2 into 1 and factorial 7. By keeping this as factorial 7, in the denominator also we have factorial 7. This saves us time while solving the question. Now without expanding the factorial 7, we can cancel these two, because look at here, they have the same value. So writing their factorials will only cause you some time. So to save the time, we can write directly as factorial 7. Again 3 3s are 9, 2 4s are 8. Answer is 120. That is same. In this way you can write it. If we have factorial say 9, then we can write n. In the denominator we had factorial 3. We can write 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, or by factorial 3. Or you can also write factorial 9 by factorial 3 as 9 into 8 into 7 into 6 into 5 into 4 into factorial 3. This saves your time. So this was all about the combination. Let us solve one example of permutation. Now let us look at the question. Arrange 10 chairs taking 3 at a time. Whenever in the question you find the word arrangement, you have to apply the formula of permutation, and whereas in case of selection you have to apply the formula of combination. Here we have to arrange 10 chairs taking 3 at a time. So we have to apply the formula NPR, which was factorial n factorial n minus r. So here 10p3 is factorial 10 factorial 10 minus 3. Since this is permutation, here factorial r will not come. So factorial 10 by factorial 7. Here we can write 10 into 9 into 8 into factorial 7 by factorial 7. Since in the denominator we have factorial 7, so we are not expanding these two factorials. Now upon cancellation we will have 9 it's a 72, 72 into 10, 720. So, similar type of question, in combination we got only 120 ways of selection, whereas in permutation we have 720 ways of arrangement. This was all about the concept of permutation and combination and their formula. In our next videos, we will be solving some problems related to this section and also the short tricks which will help us in saving time in our competitive exams. Thank you.